Hello and welcome again to the SecurityMetrics podcast. I'm Jen Stone, Principal Security Analyst for SecurityMetrics. And you guys, I am so stoked. I can't even tell you. I have with me today on the podcast a guy who I followed his work for a while. Very excited to talk to him. He's going to talk to us about security in general and also some of his solutions in particular. I hope you enjoy it. Tom Hatch from Salt Stack, creator of Salt. Welcome to the show.
Hey, Jen. Thanks for having me on.
Super excited. You know, I don't know if, so I kind of knew who you were from just because we're in the similar industries, but I didn't know a lot about you or what you had done until one of my colleagues in the pen testing department said, Jen, if you're not following the hacks, then you should be, because there's a lot of good information on there. And so I was listening to my penetration testers because they're super smart and have not guided me wrong yet. So you have a podcast. Let's talk about your podcast first, since that's what I just brought up. You guys just kind of recently started that, right? How many episodes do you have out?
Oh, goodness. I think we're 16, 17 episodes.
Yeah. Nice.
So it's still pretty fresh.
So a little bit about your background. How did you get into security?
So I used to work for the U.S. intelligence community. I've been involved in infrastructure management for a long time. When you manage an infrastructure, you care about its security. But I learned quite a bit in the U.S. intelligence community. And then with SALT, I started SALT mostly as infrastructure automation, but it was used from an very early on for cybersecurity management and primarily to roll out security fixes to infrastructures. And so security's kind of been, I should say it's been the second thing that I've been involved with throughout my career, whereas first I'm an operating system and automation guy, but there's always been cybersecurity right there next to it.
Oh, I heard also that one of your previous iterations in your career, you worked for a company called Backcountry. Backcountry.com here in Utah.
I did work for Backcountry, not for very long. That was an interesting kind of stint in my career.
The only reason I bring it up is because I too worked for Backcountry for a very short stint. And it was, so I started my career in the 90s in IT operations, and I got bored of it after like a decade. And maybe I would have stuck with it as like my primary focus if maybe the companies I had been working for had been a little bit more interesting, or the challenges that they had. But mostly I just want to do something completely different. And so I changed from that to development project management. So I went to Backcountry and I got to do their configurator for their car racks. Super fun. It was really the only software development related thing that I got to do, because then they found out that I had operations background and they're like, hey, it's taking us 12 hours to do a release. Do you think you could kind of dive into there and help us fix that? So I'm like, dang it. Yes, I will do that.
Yeah, that's how that happens.
Yeah.
Infrastructure management, it's a field where historically people just kind of get sucked into it. I know very few people in infrastructure management that, were 18, 19, went to college and said, by gum, I want to manage servers for the rest of my life.
You're probably right.
A degree in philosophy and needed to make money and happened to know how to use Linux.
Okay, so my undergraduate degree was in animal science. So
yeah.
I'm saying it checks out, yeah. So you got kind of sucked into it, and then realizing that it is dumb and takes time to be manual with any kind of infrastructure process. Is that what made you say, hey, I'm going to start automating things?
Oh, yeah. I mean, I wrote my first automation platform as a research project back in college. And then moved on and wrote another one for when I worked for the U.S. intelligence community. Then wrote another one working for a company called Beyond Oblivion, and then wrote another one called Salt. And so a lot of my motivation when I wrote Salt was to just say I'm sick of rewriting automation platforms. How about I make it open source so I can use this one again?
And I love that you just said that. So a lot of people are familiar with open source, but some people are not. Can you talk a little bit about what is open source and why you chose open source for what you wrote?
Well, and when you say explain open source, it's funny. I mean, I explain open source to another software engineer, and they go, "Oh, okay." I explain it to a business person, and they go, "Well, that doesn't make any sense." I explain it to my mother, and she still doesn't understand. um, so, open source really just means that the source code is publicly released. But the implications of that have proven to be really fascinating over the last 30 years. So when we go back in time, originally when people were writing software, there were only so many people who could even run this stuff. And so you didn't bother trying to hide your software, the code that makes it work. And so people didn't start really aggressively hiding software or concealing software and managing it in a proprietary way until the late 70s. And after that, there was already a culture of, well, we just share the software that we write. And over especially the last decade, there's so much free software. So if the source code's available, it can be used for free. But that also means that it can be extended. The modern digital economy of the world only exists because there's so much open source software out there. There's so much stuff that you just pull something for free off of the shelf and just start using it. And that has fundamentally changed how the world works. And when I originally created Salt, to be perfectly honest, on day one, I was thinking, yeah, if it turns into a company, great, but I'm just writing me some software.
Right.
And so my original motivations around open source were, yeah, I'd like to use this again. But as we grew, I continued to write open source software and support open source software because it supports this much larger ecosystem, right? Because it allows you to create much more complex and much more powerful systems when there's open source software all around you.
I agree. And actually, back to backcountry.com, it were the sysadmins who were there were the ones who originally turned me on to the concept of open source and the value that it could bring. And I've only seen that increase over time. So, as you said, you had written over and over again, probably solving the same problems by the time you got to Salt. You were seeing consistent challenges that you were facing that you wanted to solve with the software. So can you kind of give an overview of what it was, the problems you're trying to solve with it originally?
Well, the problems that we face in infrastructure management have changed a lot over the years. When we go back in time to original problems I was solving, it really drilled into a pretty simple concept that I wanted to be able to gather arbitrary information from lots of systems. And that's fundamentally what Salt is this ability to send a command out to large numbers of systems and just ask them a question really fast. So I mean, if we look at some of our customers and some of our really big Salt Stack deployments, we're able to ask a question of or make a change in an infrastructure roughly 2 orders of magnitude faster than anybody else. One of my favorites, we recently had a bake-off, right, against a somewhat similar tool that does everything with SSH. And during this bake-off, they decided one of the things was a performance test. And Salt was able to communicate with and change the password on 15,000 devices in about a half of a minute, okay, a little under a minute. And this competing piece of software, it took it about 2 hours and 45 minutes.
That's pretty significant.
To do the same task. And ours was much easier to set up to work at that scale. So, I mean, that was really the main thing I wanted to fix, was just how often it is that I need to ask my infrastructure. Hey,
Right.
can you tell me what the status is out there? I want live status. I don't want whatever a monitoring system is giving me. I want reality.
Hmm.
And then combining that with, well, if I can ask, then I can command.
Right.
So that again, that's really the foundational unit of what SALT is. And even in today's infrastructures, that problem certainly still exists.
Hmm.
Still have managed devices, whether they're servers, network switches, containers, whatever,
Sure.
and being able to ask those things a question and tell them, hey, move over here, or hey, shut down this network connection. That's still really useful.
Okay. And so, but now, you're, like you said, the challenges change over time. Um, and I'm sure part of that is security. I remember, so my dad was, he worked for RCA when they were still in the computer business, like in the 60s and 70s, right? So he was a computer programmer and systems analyst for them when it took like 6 to 12 months to go on site, set up your mainframe, and then you'd go completely different end of the country to set up the next one because there just wasn't all that work in one town, right? So you wanted to be in computers, you would travel, right? And I remember one day we were talking about computers in high school, and he was so mad because of some viruses that were happening. He's like, "Who are these people who are using these computers this way? It's going to ruin it for everyone." I mean, it was quite a rant, but it really did. You know, it went from we're all in this together, figuring this out and trying to make something work, to, hey, what if I did something a little sketchy? And to now, it's not just pranks; it's active cybercriminal activity.
Oh yeah, and the cyber criminal activity is on an international stage. I mean, we live in the era of continual cyber warfare, and that warfare is not just between nation states. It's it's between crime syndicates, crime groups, hacker groups, and they spawn from seemingly nowhere. You only need a handful of folks, or even just one person, can have a very big impact when they perform these attacks.
Right. And a lot of that comes from their automation. Um, so I work with a lot of, well, companies of different sizes, but sometimes I get this response when I try and talk to them about some of the security holes that I'm seeing and helping them put time and money towards resolving them. And they'll say, well, I'm not big enough or important enough to be a target. But what they don't understand is that you don't have to be specifically targeted anymore. The automation out there to just blast everybody with an issue is massive. And so one of the things that I really liked when I've been listening to you is the automation that you put towards closing some of the security gaps that I've been seeing.
Oh yeah, and I was astonished when a few years ago, at the end of 2018, Gartner came out with a report that said that 99% of breaches, the company that got hit already knew about the hole.
That's pretty massive.
If that's not a smoking gun, I don't know what is,
Right.
right?
Right.
Well, just so you know, almost literally all of these things, you knew that it was a problem, and then you still got hacked.
Mm-hmm.
And so that really begs the question of saying, how do we solve that last mile problem?
Right. As an assessor, I'm seeing this gap between the people who know there's a problem and the people who have to fix the problem, and then the people who have to approve that there was a problem that was fixed and they're good with the current state. It's like, the people who are running scans, the people who are implementing fixes, and then management who's saying, yeah, we're good to go. And there is not a good coordination between those three.
Oh, and we have very rarely seen a good coordination between these three. And that's entirely what we're doing from a product perspective. Is that I sat down and went through and really wanted to break down this problem set, because oftentimes we, as engineers, we get trapped in, well, I could solve this problem with code kind of mindset, but the problems we're solving are human problems.
Yes.
That we're trying to solve with code, and so we have to understand how that human problem breaks down. it breaks down in large part because of the motivations of the actors. When we come in and we've got our security analysts, as you're well aware, your motivations are to find holes.
Sure.
The motivation is that we've got to find where those issues are, but the motivation is also, how do we establish what a good security posture looks like? What are those good practices? And then in trying to achieve those practices, they have to be applied to those systems. But the cybersecurity professionals out there and analysts are doing a phenomenal job because they are finding these issues. And it wouldn't be right of us to then look at the same person and say, oh, by the way, you now need to understand the entire infrastructure deployment in Fabric so that you can fix them.
That would be a massive ask.
Yeah, well, yeah, that's a very unreasonable ask. But so what happens, of course, is that I've got a presentation I give on this, and I paint this pyramid on my slides, and it talks about how we establish policy and we scan for these things and we gather alerts, and then we've got a lot of alerts and we organize them, and then we orchestrate the alerts into different tools and we gather them from different tools, and then we funnel those alerts into artificial intelligence because we gotta know what the really bad ones are. And then once we know what the really bad ones are, we've spent, as an industry, billions of dollars.
Mm-hmm.
To know what the bad ones are. And what do we do? What do we do with this incredibly precious information that we put
really good dashboards?
We open up help desk tickets for the IT team.
Yeah.
Yeah. And then the IT team looks at it and says, I don't have time for this crap.
Yep. And it's, I mean, we joke about it, but that is absolutely true. And I see it over and over and over again.
And one of the other interesting things is that a lot of the cybersecurity companies have come out and said, hey, we're going to try and build a way to actually automate these fixes. And I was sitting down with a VP of product just a few weeks ago. Okay, it's been a couple of months because I could still sit down with somebody.
Yes.
And this is one of the dominant SOAR products in the market. And I ask, how many of these problems do you have automated fixes for that are usable? And she said, we have automated fixes for about 5%. They're usable for about 2%.
That's rough.
And I'm going, oh.
Yeah.
That's a dominant player in the market. And again, I mean, what we've done is we've said, I'm not going to make a scan without a fix unless there's a pretty darn good reason I can't automatically fix that thing.
Nice.
And so over 95% of our scans have fixes with them.
And I think this is important because, I mean, I don't want to make it sound like we're beating up on help desk guys. That's where I started, was the help desk. I feel for help desk people, right? It's not like they don't want to fix things. It's not like they don't care about fixing things. The amount of work that is on their plates just to keep things running, much less, oh, by the way, something might get hit by this vulnerability, when they're already getting yelled at to make sure functionality of tools that people are using every day is happening. That's a hard balance.
Well, and it's hard because, I mean, even internally at Salt Stack, we've had those discussions. Okay, we've got server X. It's got a known vulnerability. We just found out about it. We know that if we restart Service X after fixing it, there's a decent chance that it's not going to come back up because we hate Service X. And then we say, what's the risk?
Mm-hmm.
What's the risk? And then how much work is it going to take if it doesn't come back up? And we have to say things like, we're going to miss a release of software. And all of a sudden, the application of that fix, hey, I'm an entrepreneur. I'm a risk taker.
Right? Exactly.
Very tempting to take that risk.
Mm-hmm.
And when you start to look at that, I relate this as a story. I've got one server that's a problem that's exposed to the internet, right? Just because we don't build our internal systems that way.
Okay.
And we're trying to get away from that last service that's exposed to the internet that's prone to lots of vulnerabilities. I mean, these guys get a top tier CDE filed against them every 4 weeks, it seems.
Oh.
But so, I mean, we're trying to fix those things, but a lot of companies don't have that luxury.
No.
That's just how it is.
Mm-hmm.
And then the infrastructure people, these ops people are managing way more applications than they used to.
Yes. Well, because the business doesn't understand that they have an application they need and it's valuable to them in doing their work. And then the ops team says, hey, can we explain to you that we cannot have this application because we don't have enough people on the ops team? And the business side, they don't have a frame of reference to be able to staff or put resources towards managing a new application, because to them it's just something more that you knew that you use, and to the operations team they're like, that it's so much more than that, and we don't have the framework to talk to you about it.
Well, and the problem you just described is like we could do 10 episodes on this.
Yeah.
Because we could talk about how when a business creates and publishes an application, they do not assess the total investment cost.
Right.
When a business has an application, they say, "But I have an application.
Yeah.
It's already there. Why do I need to invest more in something I already have?" Right.
It's not like a book you put on the shelf and read occasionally. It's more like a goat that you have in a pen. You got it. I'm not kidding you. They will cause problems. They'll break out. You got to feed that goat. Yeah. And so the security solutions that you're coming up with, Salt, tell me a little bit more about that. So you have scans that you have fixes for. It's because you don't want to tell them about the problems that you don't have a fix for, or what's?
We have scans for things that we can't fix.
Okay.
When I say that we can't fix something, it's because it's highly subjective. It's something like, hey, we noticed that there's a potential security problem with how your partition table is laid out. I'm not going to give somebody a button that says, I'm just going to start messing with your partition table. Right? So yeah, we'll find it.
And to those people who, it's okay if you don't know what a partition table is. Basically, is you mess with it, you don't know what you're doing, you lose a bunch of information, it's not good. So in other words, you have the scans where they can automatically fix things that are maybe a lower risk to auto fix, and then you have scans that people have to take action on because of perhaps that there's business decisions or operational decisions behind them.
Yeah, well, and the other thing is that all the scans, all the fixes that we present, we don't just say, "Hey, you're about to blindly fix everything." That would be pure insanity.
Yeah, it would.
What we do is we execute the scans and we find the vulnerabilities, we find the misconfigurations, and then we present them all. And then the thing that's really important to emphasize is that when we find bad configurations and vulnerabilities, 90% of them, yes, you can probably just update and you're going to be fine. But the wise operations person knows which ones are dangerous and which ones aren't dangerous. Mm-hmm. And they're able to go down through that list and say, safe, 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 not sure, terrible, safe, 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 safe. And then they can push the button on the safe ones and make them go away. One of these huge problems that we have in cybersecurity in general is that we have alert overload. Mm-hmm. Way too many alerts because there are so many little holes. And if you can make the little holes go away, it becomes significantly easier for that company to rally behind, look, here's the big bad ones, here's the problems that are invasive, but we don't think they're bad. So we're okay accepting that risk. Mm-hmm. Instead of saying there's a flood of cruft that we have to go through. We can get rid of all that cruft. We can then get rid of many of the bad ones immediately so that you're focused on that little window of what are the things that are hard to fix and bad. And now, well, this is manageable because we've taken care of many of the bad ones, lots of the not bad ones, many of the ones that could be bad later.
How you say a good operations person can go through. How does something like this work for maybe a smaller organization where they're less technical? Is this a solution that you recommend for groups that already have solid IT behind them, or is there possibly a application for some of these smaller organizations?
So when you say smaller organizations, I guess one of the challenges I run into is that we've got customers that have. One of our customers has 300,000 servers that they're managing. Another one of our customers is managing 50,000 network devices.
Right.
But we've got customers that are managing 50 servers.
Right.
And we've got customers that are managing 2,000 servers.
Okay.
We rarely see a customer below 50 devices.
Well, and honestly, below 50, you can kind of scramble and do things manually.
Yeah, you can, yeah.
It's not fun, but you can. But you hit 50, and you darn well better have a good IT department, or things start falling down.
Well, and the other thing is that I say customers. When you've got below 100 or so servers, our open source software, you can usually do it with just the open source software. You don't need the dashboards necessarily. Our open source software doesn't come with all of our security scans and remediations. But again, you've got 30 machines. And you do a scan and you go, "This I can deal with this."
Right.
But if you've got 200 machines and you do a scan, that's more than you can deal with. And 30 actually might be more than you can deal with. I mean, it depends on how long ago were those systems installed.
Do you sleep or?
I say long ago, but we're actually working on a campaign where we scan and then fix, of course, stock images on cloud providers.
That was going to be my next question. How do you deal with some of these cloud instances that they're similar in a lot of ways to the legacy type of server farms, but there are a lot of differences in how they're set up and the kind of control people have over what they're doing.
Oh yeah, and so I mean I should make it very clear when I say servers, I don't mean bare metal servers exclusively, not by any stretch. I mean, we're used very extensively on cloud deployments. Heavens, we wouldn't be in business. When these cloud deployments get spun up, the stock images that are used are generally about 45 to 55% properly configured from a security perspective. They almost always have anywhere from 5 to a few hundred known vulnerabilities in their software.
I concur. I've seen that as well. Yeah.
And I'm amazed at how shocked people are when we show them that. They go, "Amazon's not giving me totally tightened up, secured images." I'm like, "No, why would they? That's your problem."
Yeah. I'll ask people, what's your hardened configuration in AWS, and the look of shock on some people's faces because they say, "Well, we use this from them," and it's hard to help them understand there's a big gap there, and it's not. I think a lot of people are led to believe that the cloud is like a magical place, but the cloud is just servers and server images that somebody else created for you.
It's just somebody else's computer.
It's just someone else's computer.
That's it.
Exactly.
One of the things that's interesting to explain is you come back and you look at something like Azure and AWS, and they publish all the security practices that they dutifully follow, and good that they do. But those security practices are to secure their own infrastructure.
Right.
1, 2. their infrastructure is way more complicated than anything you're ever going to build, buddy. And what they have told you that they are in compliance to, I hope I don't get killed for saying this. I've actually said this on the hack, so I've said this enough that I will get killed. But what they tell you that they are in compliance with only covers about 60% of the cybersecurity spectrum that is really critical for an infrastructure of that size and complexity.
And I'm not shocked by that at all.
The things I have seen inside of some cloud providers, it terrifies me. At the edge devices which have not been properly secured, and I go, well, it's a good thing, but I guess the attackers just haven't sat back and said, wait a minute, I can hit that kind of device too?
Yeah. Don't give them ideas.
I just said that kind of device. Like, I'm being vague.
I think helping people understand that it's far beyond what they think it is that they need to secure. It's kind of overwhelming to a lot of groups. But then also knowing that there are automated ways to know about it and take care of it, I think should at least give people ideas on what steps should I take next so that I know what direction to go. First of all, knowledge is half the battle. And then, because if you don't know it, you can't fix it. But then automating the fixes, I think, is some pretty big steps forward.
And it is, and there's reasons why we haven't done this in the past. There's a lot of reasons, and when we come back and we look at the cybersecurity industry, there's very good reasons why they haven't done this. One of them is that when you go into a cybersecurity tool, and you say, hey, this cybersecurity tool is going to start mucking about with your systems and your configs, it's the wrong expertise. It's coming from the wrong source. It needs to come from infrastructure management and automation. And so we have seen, again, cybersecurity companies attempt to come into these arenas, but they've really struggled to get traction. And I'll be honest, I was on a call with an investor just last night, and he basically told me I'm an idiot because this hasn't worked in the past. It's not going to work now.
Oh, because he didn't stop and think, how are you different from what has been happening in the past?
Right. You know, and my answer to that is, but we all know what an iPad is, but nobody knows what the Microsoft Jupyter was.
Right.
Just because somebody made a tablet in the past that failed doesn't mean the next one's going to fail, buddy.
I've never even heard of a Jupyter. Well, you say Jupyter, I think trumpets, but I don't think Microsoft made trumpets, so I don't know what that is.
They had an experimental project in the early 2000s to create a tablet that ran Windows that nobody used.
Totally missed it.
Yeah, we all did because it was a flop.
And yet, the iPad was a successful thing. So your point being that just because things have failed in the past doesn't mean that future attempts to make security work are also going to fail.
Right. So when we come back and we look at the progress that's been made by some of our customers, it's really astonishing. Some of the banks, some of the government agencies, insurance companies, as well as just small shops, web shops and startups that we have as customers, that they are able to come back and say that their security posture is so dramatically improved that 70 to 90% of these security alerts are just gone now.
Nice.
They've just fixed them.
Because it gets so noisy when it's just alert after alert. Yeah.
And they've come back and they've been able to say, we don't need as many of these cybersecurity tools anymore. We still need them, don't get me wrong, but many of these organizations they had redundant scanners. They had tools that were only existed because of the sheer volume of alerts. Mm-hmm. And when the volume of those alerts starts to go down, you're able to say, oh, wait, there's light at the end of this tunnel. We can actually deliver security.
Nice. Well, and on that positive note, I really appreciate you coming on and talking to me, understanding that there is an automation side to cybersecurity. From my perspective, a lot of people don't understand that. They don't know that that's even a possibility. So I appreciate your time talking about that.
Well, and Jen, I can't thank you enough. I love what you guys are doing, and I love your podcast.
Oh, thank you.
And you've been more than kind, because you've let me come on here and just talk about myself the whole time.
That was the whole idea. I was so excited to learn more about you and what you've got going on, and thank you so much for taking the time.
Okay, thanks, Jen.
All right, take care. Thanks for joining us again here at SecurityMetrics Podcast. Really appreciate your time, and Tom Hatch for joining us and telling us all about security automation. Take care. Thanks for watching. To watch more episodes of SecurityMetrics Podcast, click on the box on the left. If you prefer to listen to this podcast, it's available on all your favorite podcast platforms. See you on the slopes.